In this video, we are going to learn about a technique called titration. In titration, we're going to use stoichiometry, and as we said, stoichiometry is the mole ratio between reactant and reactants and reactant with products. So far, whatever we've learned was using the relationship between reactants to products. In titration is basically a technique that you can find the concentration or the amount of one of the reactants with the other reactant. So they do the titration until you reach the end point, and there are ways to figure out what is the end point that I'm not going to go into details, but you can read your textbook to become more familiar with the technique. So what we are doing in this video, we are going to learn how to do the calculation in when we have relationship, stoichiometry, relationship between two reactants. So we are going to combine the molarity and stoichiometry. So let's write the formula that we are using for molarity. How do we find the molarity? You know, the molarity is mole over liter of the solution. Mole of the solute over liter of the solution. Okay. If we solve this formula for moles, we will have mole is equal, not molarity, erase this. So mole equal molarity times volume in liter of the solution. Okay, sometimes I write L, sometimes I write V because it's a volume, right, in liter. So M times L or M times V. Okay, molarity times volume of the solution. So that will give us the mole, and if you remember, that's the base of the stoichiometry, right? So in stoichiometry, we use the mole ratio in a chemical equation. So this is actually a conversion tool. The molarity is a conversion tool that we've already talked about, that you can use it to convert the volume of the solution, the liter of the solution, and use the molarity as a conversion factor to go to the mole. Okay, so this adds to our stoichiometry um, toolbox. So we can start with the liter, we can use molarity, go to the mole. When we reach the mole, we can go across the chemical equation with the coefficient of the balanced chemical equation, right? So we can go across anywhere, and then we can go back to molarity, we can go back to the liter, you can go back to the mass. It depends what we want. Okay, so you have to read the question and see what route you need to take to go into the final answer. Okay, so let's have some practice. Okay, so we want to know how many grams of sodium chloride are required to precipitate all the silver ion in a solution of 125 milliliter with this concentration of silver nitrate. Okay, so we have one silver nitrate solution, and we can make, or we have sodium chloride solution, or we can weigh out the sodium chloride and make the solution. Okay, so the first step is to write the chemical equation, because for stoichiometry we need the balanced chemical equation. Okay, so sodium chloride is mixed with silver nitrate, and we know both of these are soluble in aqueous solution, so it's aqueous, and they're going to make, you have to swap the partners, right? So I don't write the details, I just write the final equation because you probably know how to do that. So it makes silver chloride, they're swapping the partners, and sodium makes a compound with nitrate, so we have sodium nitrate, and nitrates are all aqueous. Okay, so you have to check if it's balanced. and yes, it is balanced. So we have the balanced chemical equation. So what information do we have? So we have the molarity of silver nitrate. So we know the molarity is 0.0081 molar, and we have the volume. So we have 125 milliliter of this solution. What do we want? We want the mass of the sodium chloride. How can we relate silver nitrate with the sodium chloride? So it's asking how much sodium chloride is required to precipitate all silver ions. So we have to use all silver nitrate or silver ions in order to make AgCl, right? So uh, how can we relate silver nitrate to NaCl? We know in stoichiometry we can only travel through the compounds over only over the mole bridge, right? So we need to go to the mole of each of them so we can uh, have a trip over sodium chloride, and then we can find the mass. So the first step is using the volume going over mole. How can we use volume and go to mole? We can use molarity, right? So we use the molarity going from mole, the volume, the milliliter, to mole. That's the first step. And then the second step is using the mole bridge, using stoichiometry, to go to the mole of the sodium chloride, and then from mole of the sodium chloride we can go to the mass of the sodium chloride. Okay, so let's do that. So we start with the volume, 125 milliliter. Okay, so uh, we can use the molarity, but we know molarity is mole over liter, right? So we don't have liter, we have milliliter. You can either use a conversion factor to convert milliliter to liter, or I've already talked about this in molarity video. So it become easy after a while. So I know that 125 milliliter is 0.125 liter. Okay, but I don't know whichever you feel more comfortable. So if you feel comfortable to just make it liter, start with liter. If not, start with a milliliter. So let me erase these. Start with a milliliter and then use a conversion factor. Let me erase everything to make it to liter. Okay, so I start with a milliliter. So 125 milliliter. Before I use my molarity to convert to mole, I need to make this to liter. I know 1 milliliter is 10 to negative 3 liter. So now I have the liter. And what is this liter of? What is this volume of? It's a volume of silver nitrate. So the milliliter of silver nitrate, and this is silver nitrate. Okay, so I don't want the volume of the silver nitrate, I want the mole of silver nitrate. So not the liter of silver nitrate, I need the mole of silver nitrate. So how can we relate liter to mole of silver nitrate? So we can use molarity. So molarity is mole over liter, right? So if you have the molarity, it means 0.0081 mole of silver nitrate is in 1 liter of silver nitrate. So right now we have the mole of silver nitrate. So that's the first step. We had one pre-step before the first step to convert milliliter to liter, but this is our first step to go to the mole. The second step is using stoichiometry, going from mole to mole of sodium nitrate, so sodium chloride. So I don't want the mole of silver nitrate, I want the mole of sodium chloride. And with the balanced chemical equation, 1 silver nitrate needs 1 sodium chloride. So 1 mole of silver nitrate needs 1 mole of sodium chloride. Are we done? No, we need a third step because we need the grams or the mass of NaCl, right? So that was our, not the third, the second step. And the third step is going from mole to mass of sodium chloride. And how do we do that? Molar mass, yes. So I don't want the mole of sodium chloride, I want the gram of sodium chloride. And what is the molar mass of sodium chloride? It's 58.44 gram of sodium chloride is 1 mole of sodium chloride. So are we done now? Yes. So let's see, that's the third step. So going from mole to mass. So milliliter of silver nitrate with milliliter, liter of silver nitrate with a liter, mole of silver nitrate with a mole of silver nitrate, mole of sodium chloride with mole of sodium chloride, and we end up with the mass of sodium chloride. And that's what we want. It says how many grams of sodium chloride are required. So the rest is just putting these numbers in the calculator, and the number you get is 0.059 gram of sodium chloride. So in order to precipitate all the silver ions in 125 milliliter of this concentration of the silver nitrate, you need to weigh out 0.059 gram of sodium chloride and make a solution out of it and mix it with silver nitrate. Okay, we have another example. We have 22.5 milliliter of 0.383 molar sulfuric acid is required to completely neutralize. So what was neutralization reaction? It was acid-base reaction, right? To neutralize 20 milliliter of KOH, potassium hydroxide solution. And it's asking for the molarity of KOH. To find the molarity, we need the moles of KOH over the volume of the KOH, right? So we have the volume of the KOH, so we have to find the mole of KOH first to find the molarity, okay? So the first step is always writing the balanced chemical equation, right? So we have sodium, oh, not H2O. We have sulfuric acid, H2SO4, and we are mixing it with KOH, potassium hydroxide. So it's acid-base reaction, right? Sulfuric acid is our acid, and potassium hydroxide is a base. So what do we make when we are mixing acid and base? Salts and water. So what is our salt? We have the cation from base, potassium, and the anion from the acid. So we have KSO4, and you know it's 2 minus and 2 plus, so it's K2SO4, and it makes water, H2O. So this is aqueous, this is liquid, and these two are aqueous. Okay, so we need to balance that. We have 2H plus here, so I need 2H plus. Over there we have 2OH, so 2OH and 2 potassium, it is balanced. Okay, so now I have the balanced equation. I didn't go through the details, you probably know how to, you've had enough practice, but this is the balanced chemical equation. Okay, so what do we have? We have the volume for sulfuric acid, so we have 22.5 milliliter of the sulfuric acid. We have the molarity, so 383 molar. And what do we want? We want the molarity of KOH, right? So how can we relate these two together? We have to go over the mole bridge, right? So let me erase this line over here. Okay, so I know that I have to go to the mole of sulfuric acid, and from there I can use the mole bridge to go to potassium hydroxide, and then we can use the volume to go to the molarity. Okay, so but I need the mole first. So the first step is to go to the mole, and then from mole go to the mole of potassium hydroxide, and then I can divide it by the volume to find the molarity. So let's start with the volume. So I have 22.5 milliliter of sulfuric acid. Before I go to the mole, I need to make that liter. So 1 milliliter is 10 to negative 3 liter, and this is milliliter and liter of H2SO4. Okay, so I don't want the liter of H2SO4, oops, SO4. I want the mole of H2SO4. And how can I convert volume to mole? Molarity. So 0.383 mole is 1 liter, right? So now I have the mole of sulfuric acid, but I need the mole of KOH. So I don't want the mole of H2SO4, I need the mole of KOH. And from the balanced chemical equation, I could see that 1 sulfuric acid needs 2 KOH, right? So 1 mole of H2SO4 requires 2 moles of KOH. So I'm going to stop here and find the mole of the KOH first, and then I can divide it by the volume. So I can cancel milliliter of sulfuric acid with milliliter, liter of sulfuric acid with liter, mole of sulfuric acid with mole of sulfuric acid, and end up with mole of KOH. So if you put these numbers in the calculator, the number you're going to get is 0.0172 mole of KOH, and you want the molarity, so you have to divide it by the volume, and the volume should be in liter. You know the volume of the KOH is 20 milliliter. I straightly go ahead and make it to liter, so you just move the decimal place 3 digit to the left, and it's 0.02 liter of KOH. So the molarity of KOH is 0.862 mole over liter. That's the molarity of KOH. Okay, so if you use 20.5 milliliter of this concentration of sulfuric acid to neutralize 20 milliliter of KOH, the concentration of the KOH should be 0.862. Okay, that's titration. So you can read more about titration technique in section 5.9 in your textbook. Basically, what we do in acid-base titration, we measure some specific volume of one of the solutions that we do not know the concentration of that, and we do the titration. So we add usually it's like we add the unknown solution in the flask, so the volume is known, the molarity is not known, and we add the other reactant that we are going to do the titration with in the burette. If you've done the labs, you know how to do that, or you're going to practice to do the titration. So you add the solution that you know the volume, you know the molarity, and you will know the volume how you start adding the solution from the burette to the flask, and you continue until you reach the equivalent point. And there are some techniques to know when the reaction is done, so it changes the color, and there are some techniques that you will learn more about it. I think it should be in a textbook, or maybe in the next chemistry classes that you're going to take. So you're going to know when it is done, then you stop the stopcock, and you can read the volume. The burette is graduated, so you can read the start line. When you add the burette, when you want to start, you can see the volume, and then when you stop, you see the difference, so you know how much volume of the solution in the burette you used up. So you know the molarity, and you can read the volume, so you know the molarity and the volume. You can use the calculation we used in the previous slides to find if the volume is known, because you know how much of the solution you took, right? You can use a graduate cylinder and take, for example, 20, just like the previous question. We know the volume of the KOH, we didn't know the concentration. So you know the volume, you can solve it for the concentration of the other solution. And as I said, you can read more about the technique in your textbook.